In this video, we're going to go over algebraic manipulation. That's taking a mathematical equation and solving for one variable. And we do this by rearranging it. And this is a lot of times called solving for x. Now, equations are typical in science. You may see the equation of a line, y equals mx plus b, or an equation for density, or the ideal gas law, or something like the combined gas law, P1V1 over N1T1 equals P2V2 over N2T2. Now, you may not have used these yet in general chemistry, but these are just some examples of different equations. Now, a lot of the problems, you'll be given a bunch of variables, except for one, and then you will have to solve for that last variable. So what we're going to do in this video is we're going to go through what an equation is, what it means to be in the numerator or the denominator of a fraction, how to solve for x, the correct order of operation, and then something called cross multiplying. And then at the end, we'll do a bunch of examples. So first, an equation is a mathematical statement showing that two mathematical expressions are equal. So for instance, we could have 100 minus 5 equals 95, or E equals MC squared, or P equals nRT. The left side of that equal sign is equal to the right side. And that's a key thing in these equations. Whatever we have on the left and right are equal. Now, one thing we can do is we can do the same mathematical operation to both sides, and they will still be equal. And by operation, I could mean addition or subtraction or multiplication, division, or square it or square root. So let's say we had 100 minus 5 equals 95. And we decided to, let's say, add 50 to both sides. Well, I'd have 100 minus 5 plus 50 equals 95 plus 50. Well, the left side, 100 minus 5 plus 50 would give me 145. And I'd have 145 on the right-hand side. I have to do the same thing to both of them. Let's say I had PV equals nRT. Well, let's say I had PV equals nRT. If I wanted to divide both sides by 3, I could get that PV over 3 equals nRT over 3. It's okay to manipulate it by doing the same thing to both sides. Now, let's understand a little bit more about fractions. So you may remember this from when you first dealt with fractions. We have numerators and denominators. The numerator is the top of the fraction. So for instance, x over 3. The x is in the numerator. Or if I have just 2x. Now 2x isn't a fraction, but it's the same as 2x over 1. So here, that x, it's in the numerator. Now, a key thing is if a variable is in the numerator, like x, if x increases, the entire number increases. So if I have x over 3, and let's say x was equal to 1, that means that this value would be 1 over 3. Well, let's say I increase x to 3. Well, now I'd have 3 over 3 or 1. So increasing x increased this value. Now let's go on and let's figure out what a denominator is. A denominator is the bottom of the fraction. So for instance, 4 over x. Here, if I have 4 over x and x is equal to 1, well, 4 over 1 would be 4. But let's say I increase x. So now x is equal to 4. So I'd have 4 over 4, so that'd be 1. So increasing x decreases the value. That's whenever that variable is in the denominator. Now, a key thing when we're dealing with numbers is that 1 over x does not equal x. Okay? So always be aware of that. So if you get an answer and you get 1 over x, right? Sometimes we just say, okay, well, x is my answer. No, we have to do some manipulation to figure out what x is still. So now, how do we solve for x? A lot of times, in order to solve for x, and by solving for x, we mean isolating x, so that we can get something where it's x equals whatever. What we do is we do the opposite operation. So let's say we have some addition and subtraction problems like x plus 5 equals 76 or x minus 10 equals 23. Well, to isolate the x in the first one, because there's the addition, we subtract 5 from both sides. Remember, we can do any operation as long as we do it to both sides, we're all good. All right, so x plus 5 minus 5 equals 76 minus 5. The plus 5 and minus 5 will cancel out, so I get x equals 71. So here, because it's an addition, I had to do the opposite, subtraction. Let's look at this second one. X minus 10 equals 23. Here, I'm going to add 10 to both sides, and I would get x equals 33. And this makes sense because if I add 33 minus 10, oh wait, I do get 23, so it checks out. Let's look at this if we have multiplication and division. So if I had x over 3 equals 59, well, here I want to get rid of this 3. Because remember, my whole goal is to get x equals something. So here, because that 3 is in the denominator, I go ahead and I multiply both sides by it. So I have x equals 59 times 3. The 3 over 3, those canceled out. Right? So I don't have to worry about that. So if I do 59 times 3 on my calculator, I'm going to get 177. How about 48x equals 120? 48x equals 120. Here, I'm multiplying the x times this 48. So to get rid of that 48, I need to divide by 48, but I do it to both sides. That's going to get me x equals 120 divided by 48, or 2.5. Let's look at one other case. Let's say we had 29 over x equals 99. Now this is a case where the x is in the denominator. It's on the bottom. So what I want to do is, because it's annoying if they're in the denominator, I want to get it out of the denominator. So what I do here is, because this problem is 22 divided by x, well, what I do is I multiply by x. So I take 22 over x, I multiply this by x, and I take 99 times x. So I'm doing the same thing to both sides. On the left-hand side, the x's will cancel out, and so I have 22 equals 99x. Now, just like we had before, here, now I need to get rid of this 99, so I divide both sides by 99. So I get that x is equal to 22 over 99, or 0.22. Okay. So remember, notice here, if x is in the denominator, if what the variable we care about is in the denominator, we have to get it out of the denominator before we can do any work. So now let's go on and let's look at orders of operations. So when we are doing calculations, we learned that we have a set of operations and we do them in a specific order. Right? For instance, if anything's in parentheses, we do that first. Then we do multiplication or division, and then at the end, we do addition and subtraction. So let's say I had this. This is how we how we convert from degrees Fahrenheit, which is the temperature system we use here in the United States, to Kelvin, which is what we use in a lot of scientific experiments. This is the calculation. So let's say it's 90 degrees Fahrenheit. Fairly warm day, not a super hot day, but fairly warm. So I could plug that into this equation. And first thing I do is I do the parentheses, the 90 minus 32. So I'll get 5/9 and 90 minus 32. That'll get me 58. Then I do the multiplication, so and division. So 58 times 5 divided by 9 is 32.22. And then I do the addition. Okay, so I add 273.15, and I get, that is 305.37 Kelvin. So when I do calculations, I go parentheses first, then multiplication, division, and then addition, subtraction. Well, what happens if I want to rearrange this equation and I want to take this equation, Kelvin equals 5/9 parentheses Fahrenheit minus 32 plus 273.15, and I want to solve for Fahrenheit. We want to do this a lot of times, take an equation and rearrange it. So in this case, in order to do it, I do the opposite of how I did the calculations. So remember when we did calculations, we started with parentheses. That's going to be the last thing we do. So here, if I have Kelvin equals 5/9 Fahrenheit minus 32 plus 273.5, the first thing I do is I take both sides, remember both sides, and I need to get rid of that 273.15, so I subtract it from both sides. Oops. All right, so that'll be Kelvin minus 273.15 equals 5/9 Fahrenheit minus 32. Right, the 273.15 is now gone from the right-hand side. Now I can take this, and I have 5/9 here. I can multiply both sides by the opposite of this. That would be 9/5. So I'd get 9/5 times the Kelvin minus 273.15 equals degrees Fahrenheit minus 32. And now, right, now I can do that operation that was in the parentheses, right? So I add 32 to both sides. So I'd get 9/5 in parentheses Kelvin minus 273.15 plus 32, and that's going to be equal to my degrees Fahrenheit. So this would be the case if I had a calculation and I get Kelvin, and I want to know what temperature that is in everyday life, at least here in the United States. Okay, so that's how we convert. We do the opposite order of what we usually do for calculations. Now let's do a little trick called cross multiplication. Cross multiplication is a trick in order to take two values that have denominators and make it easier to do. So let's say we had 3 over x equals 4 over y. What we can do is move the denominator from the left side and move that to the numerator on the right side, and take what's on the denominator on the right side and move that to the numerator or the top on the left-hand side. So I get 3y equals 4x. Now this may look like it's a little bit of a trick, but the math is is legit, right? What I'm doing is, hey, I have 3x equals 4y. Well, I can multiply both sides by x. So that will give me 3x over x equals 4x over y. The x's will cancel out. So I have 3 equals 4x over y. And then I could multiply both sides by y. So that will get me 3y equals 4x y over y, or 3y equals 4x. Okay? So cross multiplication is a nice way, and a lot of times we use that as the first step in calculations. So let's look at an example. Here, at 3.2 equals 1.2 over v. And so this is a little bit different than the previous one. In the previous one, I had something over x so equals something over y. Here, I don't have that. But, really, if I have 3.2, that's the same as 3.2 over 1, right? So I could take and move this over to here. So I could get 3.2v equals 1.2 times the denominator from the left-hand side, that's 1. So that kind of just goes away. So I get 3.2v equals 1.2. And we do this a lot of time as the first step because getting things out of the denominator just makes our life easier for the next steps. All right, so we talked about equations. Remember, when we have equations, the two sides are equal, right? So if I do the same thing to both sides, that's okay. We talked about numerators, that's the top of the fraction. Denominators, that's the bottom. If something's in the denominator, we usually want to get it out. That's what we do a lot of times for solving for x. And for solving for x, we do the opposite operation, and we usually do them the opposite order of our typical calculations. And we cross multiply a lot of times as our first step in calculations. So let's do some examples. Let's say we want to solve for v and d equals m over v, then solve for x in these two equations, and then n2 and v1 in the bottom ones. So I suggest you take a little break, you pause it, you try to do these, and then we'll do them together. So let's do the first one. So we have solve for v and d equals m over v. Now this is a density calculation. If you don't know about density yet, haven't covered it, doesn't matter because the math is the same. Whether it's density, you know the meaning behind this or you don't. All right, so if I have d equals m over v, and I want to solve for v, well, remember what we said. A lot of times the first step is to cross multiply, right? To get things out of the denominator. So I want to take what's on the denominator on the right-hand side and move that to the left-hand side. So I'll get dv equals m. And if I had a denominator over here, I don't, I would move that over to the right-hand side. So I'd get dv equals m. Now everything's out of the denominator, so it's nice. So I want to get the v, so I have dv equals m. So I'm taking what I care for, the v, and I'm multiplying them by d. So what do I do to get rid of it? I divide by d. That means that the d's will cancel out, and I'll get volume, or v, equals mass m over d. Let's do two examples of solving for x in these two equations. Now, these two equations, again, you don't need to know the science behind it yet, but these are what we call an equation of a line, right? A lot of times we'll get a slope, we'll get a y-intercept, we might get these from a graph of some data, and then we have a y value and we plug that in here. So anyway, let's say we have these two and we want to solve for x. So we have 2.3 equals 6.2x plus 0.05. Notice we want to get the x by itself. So we have a multiplication here and we have an addition. So what do? We do the opposite order of how we usually do calculations. So that means we do the subtraction in this case first. So I subtract 0.05 from both sides. So 2.3 minus 0.05 equals 6.2x plus 0.05 and minus 0.05. So these two cancel out. I get 2.25 equals 6.2x. Now I divide both by 6.2. And that's going to get me that x is equal to 2.25 divided by 6.2. And that's 0.36 as our value. Now notice the next one is the exact same thing, except I have different numbers. Why is this important to know? Because we do these types of equations of line a lot of the times. So again, we start off with our 10.8 equals 0.251x minus 1.2. I want to get rid of this 1.2. So in this case, I'm adding 1.2. So that'll get me 12 equals 0.251x. So my x, remember, is what I care about. Here I'm multiplying it by 0.251. So I do the opposite. I divide both sides by 0.251. And that gets me that x is equal to 12 over 0.251 or 47.8. That is our x in this case. Now let's do one. This is a combined gas law problem. Don't need to know that. But let's say we have this crazy equation, P1 over N1 T1 equals P2 N2 T2. The 1 and 2, those signify different conditions or different states. But I want to solve for N2. Notice that N2 is in the denominator. So what do I do to get rid of things in the denominator? Right? To simplify, I cross multiply. So I'm going to take P1 times the denominator over here on the right, N2 T2, equals the numerator on the right times the denominator on the left. So I cross multiply. So I now have P1 N2 T2 equals P2 N1 T1. Now I want N2 by itself, so I need to get rid of everything else. In this case, that's P1 and T2. Remember, if I do it to one side, I have to do it to both sides. N2 equals P2 N1 T1 over P1 T2. These would cancel out. Let's do one more problem like this. Let's say now we have P1 V1 over T1 equals P2 V2 over T2, and we want to solve for V1. Okay. Well, here we don't necessarily have to cross multiply, but in this case, we don't have to cross multiply because V1's already in the numerator. But a lot of times it's just easier to do it. It just makes life easier. So I'm going to take P1 V1, right? So that's the numerator from the left times the denominator from the right. And I'm going to then take the numerator from the right times the denominator from the left. And so now I have an equation where I don't have anything in the denominator. It just makes my life easier. Now I want to go ahead and I care about V1 right here. So what do? I cancel, or it's multiplied by P1 and T2, so I divide by those two. They'll cancel out from the left-hand side like we want. So I'll get that V1 equals P2 V2 T1 over P1 T2. So that is how I would do this equation, right? Remember, cross multiply makes life easier. So that is it for algebraic manipulation. Remember, the key thing is if you do things to one side, you have to do it to the both. Try to get things out of the denominator as early as possible, and a lot of times that means cross multiplying. All right, bye-bye.